All right. Well, good afternoon, everyone. My name is Paul Holthus. I'm the founding president and CEO of the World Ocean Council. So we deal with the big blue planet and the water that's of the marine and salty version. But today we're focusing more on the freshwater side of things in this session entitled "Technology Tackles the Problem of Water." And so we've got a great group of panelists here. And what I'd like to do is first just introduce them by name and affiliation, and you've got all the bio information in the app and in the materials available from the conference. So first, to my immediate left, we have Oliver Cunningham, who is the co-founder of RanMarine Technology, based in the Netherlands. Then we have Atle Idlen, who is the general manager and managing director of Desert Control. Followed by, further to the left, we have Ashwin Madgokar, who is the founder and CEO of Ceres Imaging. And last but not least, we have Gavin van Tonder, who is the head of the water sector for the NEOM development in Saudi Arabia. And I'd first like to acknowledge that Ashwin and Oliver were both finalists in the Zayed Sustainability Prize. And in fact, Ashwin and his company, Ceres Imaging, was the winner of the Zayed Sustainability Prize. So we've got so pleased to acknowledge that, both of them being through to the finalists and Ashwin taking home the prize on that. So we've got some great technology innovators and providers, and also with the NEOM project that Gavin represents, some significant use of technology and drivers for technology use. And we have, by coincidence, a great sort of kickoff point to bring to your attention that just came out today. The World Economic Forum report that just came out has identified through their analysis that the number one risk factor for the coming decade, and so this is risk in terms of both the impact it will have and also the likelihood of this happening. And that number one risk factor is water scarcity. And so the report indicates that 1.8 billion people will not have access to safe water by 2025. So this really sets the context for the urgency, the importance of dealing with water, and moving into a discussion about how technology is tackling that challenge, and what sort of in turn challenges are creating difficulties for technology being developed and getting deployed. But just to start off with, when we had our discussion as we were getting ready for this session, and Atle brought to our attention this report and the identification of water scarcity as the number one risk, then Gavin jumped in to say, well, it's not actually water scarcity that's the problem. So I'll start with you, Gavin, to sort of take us from that point in terms of how you re-articulated the problem.
Very good. Thank you for putting me up front. So when you're developing out a region like NEOM, where you have 450 kilometers of coastline, it's really tough for me to say that we have a water scarcity problem, because the water's right next to us. For me, the Kingdom of Saudi Arabia has done an amazing job at delivering water to Riyadh from the coast at a very low cost. And in the Kingdom, we now have desalination plants that are producing water at less than $0.50 per meter cubed. So there's exceptional work has been done in getting the cost down and making water low enough cost so that everybody has access to it. In NEOM, if we look at how we are going to develop out the region, the cost of water is even going to be lower than that. So for me, it's really around how we utilize the water, how we are using the water. It's not around the production of the water. And if you look in the world today, on average, 32% of the water is lost through non-revenue water before it reaches your house. Fields are irrigated in open field manner, and these are where the issues are for me. It's not around water scarcity, it's around the poor way we utilize the water and the lack of attention we pay to the water.
So if we think about then, it's about availability and access and having the right quality and amounts of water in the right places for humans. And with agriculture being by far the biggest user of fresh water, one of the challenges for the planet then is really to understand how to find solutions for how agricultural production makes use of water. And so maybe Ashwin, if you want to, it's I think a segue from the agricultural side of things into the technology and the innovations that you've developed, and maybe to put that into, before getting into the specifics of what you're doing, maybe a bit of the context in terms of agriculture and water and the challenge moving forward in this decade.
Yes, absolutely. Excuse me. And yeah, as you know, agriculture is about 70% a user of the global water supply. And so in thinking about water, it's got to start with agriculture, given the materiality of it. And when I'm originally started in the energy industry and got interested in agriculture through bioenergy and biofuels. And when I started working with farmers, I observed that they would try to maximize yields. And in maximizing yields, they would over-apply water and fertilizer and really all of their inputs so that they didn't leave any money or yield on the table. Now, however, in the face of climate change and increasing weather variability, depleting groundwater tables, and other factors, that old way of working and over-applying is no longer practical or feasible. And that's something that I've observed really in agriculture all over the world. So in order to deal with this changing context, farmers are not going anywhere. The world needs to eat. And in order to adapt to a decreasing water availability, it's important to use, in my opinion, data to apply, instead of over-applying water, apply the right amount in the right place at the right time. So there's a variety of data solutions with the advent of big data that we've had in the last decade, including things like soil moisture sensors that will help farmers understand how much water to apply. And then what our technology does is we do aerial imaging and analytics for the farming industry. So we can show at a plant level where people are overwatering or underwatering, and where that might be an irrigation issue or a soil problem, for instance. So using that, we can help farmers dial in their water amount and get the most bang for their buck, increasing their yields while also maximizing their sustainability.
And so as we think about then the amount of land that's used for agricultural production, improving efficiency through the sort of technology you're providing, though there's also a lot of land that's not being used, and this is maybe Atle, we didn't really kind of plan this sequence, but you guys are lined up exactly right. Yeah. So Atle, to talk about how land is being used and what sort of things are being done to improve agricultural productivity and the sort of work that you're doing.
Absolutely. I'd just like to follow up what my colleague just said, that the overwatering, that has been the big problem. But now there are solutions out there, and our company, Desert Control, also provides one solution, an organic solution, a liquid solution that will reduce the water needs in agriculture for up to 50%. This is just one solution, but there are many out there. But combining this with smart technologies that be sensor-based, that be telling the irrigation system when to water, when the crops are healthy, they don't need more water. So all these technologies are really available today, but I think it's the adoption, who's going to do this first. That's where the game is currently. We are working with deserts, and we believe that deserts is an untapped big potential for open farming and agriculture still, based on the technologies that are out there. Unfortunately, we see that 12 million hectares of arid land is lost every year, 3 times the size of Denmark, due to desertification around the world. So this also needs to be stopped to utilize this for food production.
And maybe just to give a little bit more about the product that you have as well, and what kind of innovations are going on there in terms of...
Yeah, it's a 12-year in R&D and testing and failing around the world. But now we have a patented solution based on clay, water, and air, which is applied onto desert and poor soils, and really regenerating the soils to be fertile. So this is being rolled out as we speak now in the MENA region in 2020.
Yeah, great, thanks. And I think to really then bring this around to some of the information needs and also the quality of water, and maybe to Oliver, for you to talk a bit about the technology you've developed as part of, and the problems that it's tackling within the scope of the sort of the water issues that we're dealing with here.
Thank you, Paul. Right, so my company makes a drone called the Wasteshark, and it's the first drone in the world to be designed to extract unwanted material from water. When I say unwanted material, I'm talking obviously about trash, plastics, microplastics, oil, toxic algae, even invasive plants. At the same time, the drone also collects data. It can collect any sort of data you need, which it can then share with your smart city, which in turn supports evidence-based decisions. So decisions become faster, more timely, more effective, and therefore reduce the total costs of running the city. Now, the human behavior patterns or trends that we're looking at, we know that our world population is growing. We're currently at about 7.5 billion. Current projection is that we're going to level off at around 10 billion. And we're also urbanizing rapidly. So we're presently about 55% urbanized. By the time we hit that 10 billion mark, we're probably going to be 75% urbanized. So that means that cities are going to be the great consumers of water and the great producers of waste. So what our Wasteshark aims to do is to help make these cities as efficient and comfortable as possible. Our drones act as a swarm. They communicate with each other as well as with the city. And they basically stay in the water 24 hours a day as a responsive membrane sitting between human society and the ocean beyond. Any unwanted debris that gets into the water, our drones will collect. So we're looking to protect the oceans by serving cities.
And do you feel that that there's been, and I put this to the three of you closest to me, is there enough connection between the needs and the users of the technology and innovations that you have all been working on, and yourselves as innovators, or is there, as we were hearing from Gavin, that sometimes those that are needing technology are not necessarily being able to access it easily enough? Is there a disconnect there, and is technology being accessed and scaled up quickly enough to really tackle the problems that you're seeking to address? Go ahead.
Yeah, I'll leap in. I'll take the safe answer, which is yes and no. I mean, there's a new breed of impact entrepreneur, arising in the world. I would define an impact product as a product that creates simultaneous value at all three levels of recursion: the economic level, the social level, and the environmental level. Traditionally, humans as a species have been very good producers and consumers and very bad recyclers. If you look at every resilient ecosystem on the planet, except human ecosystems, you've got producers, consumers, and recyclers operating in perfect balance. as a species, we're now waking up to the fact that we need more recycling, and that means better waste organization. But then, there's an existing economic system that a new product has to fit into. Now, for us, we're the first of our kind in the world. So, we're offering not just a new product, but we're obviously not the first to do it, but we are part of a new way of thinking about how economic value can and should be generated. And a lot of people are very receptive to the ideas. It takes a bit of time to get into the systems that you need to get into.
Yeah. Is that a similar experience, Atle and Ashwin?
Yeah, I can also just comment on that a little bit. I mean, I think it's about, what you say, behavior as well. We have as humans, a tendency to business as usual. That's the easy way out. And coming in with disruptive technologies, like we all kind of have, it takes somebody to jump on it and to go for it. So if you look at, as you just said, it's maybe not a water scarcity, but it's the use of the water. That's the main problem. And but today, with all the technologies, smart farming, precision agriculture, as it's called as well, there should be possibilities to get even more yield with 50% less water and better solutions.
Yeah, in our experience, if you think of it like there's the customer, and then there's us as the innovators. It's really important to have a glue layer in between, because any sort of new technology needs the right sort of training, education, and implementation for the customer, for the farmer, in our case, to use it effectively. In order to provide more of like a full solution, as like the data that we provide, if no one uses it, it's pretty much useless. And the coaching and help that we give farmers ends up becoming a really valuable piece of what we do. So in addition to just the technology, we've also focused on an implementation or even like a consultative layer, and it's a real consultative sale that we're creating a new market from scratch and really evangelizing an old school customer base. And so that education and training piece, I think, is like really crucial to make any sort of new technology work.
Can I add one more thing, Paul?
Sure.
Sorry. Inside our economic system, there's this concept of external costs or externalized costs. And these are costs that either we can't measure or we choose not to measure because we don't want to know what the answer is. Okay? And the economic system that we currently have actually incentivizes people to look for externalized costs because you can factor those out of your pricing model, which means that you can take your product to market at a cheaper price, which makes it easier for people to buy. And externalized costs are ones that we ignore. We kick that can down the road. No one pays for them now, and planet Earth pays the bill later. Now, that bill is being called in right now, and that's why water scarcity over the next 5 years is going to be the #1 problem facing the planet. Now, I think at a topmost level, I think political leaders do recognize that fact. But they've got to find a way to change the economic system, to get all producers and consumers to think along those lines, because the great majority of products only seek economic value, and therefore are incentivized to find externalized costs.
So in that sense, in terms of the role of government at different levels and the policy or regulatory environment that both identifies and seeks to address the issue and also can incentivize or spur or otherwise accelerate the uptake of solutions. And we'll go to Gavin first on this because of the role of government in being the driver of that major development at NEOM. And then to hear from the others of you, do you feel that governments are understanding the role that they must play then to deal with those externalities and create the kind of drivers and incentives for technology to deal with this #1 risk issue of water? So Gavin, the NEOM is an exceptional set of circumstances where government is playing a role of creating an urban region from scratch, and do you think there'll be lessons there in terms of policy and regulatory developments that will help the already built-up world and expanding human population elsewhere be able to better deal with this water connection with human habitation?
Yes, indeed. I mean, this is the intent of NEOM, is to implement future technologies, not only future technologies, but future ways of working in a region that can be a model for the rest of the world. But not only to do that, to do it in a sustainable way. Okay, sustainable for us is actually the short version. We not only want to be sustainable, we want to enhance the environment. An example of that would be desalination. Today we are looking at solar desalination, direct solar desalination, and I know a lot of energy people out there want to make energy out of solar and then sell it to us so that we can then make water. And we're saying, why don't we cut out the middleman and make water directly from the solar sun? And we're going to be implementing one of those technologies inside NEOM in this year, in fact. But I have the enviable task of putting a water utility in place and looking at the way water utilities around the world. And if you're in the water industry, then you will know that it's a very, very conservative industry. And looking at the regulations around what we do there to enable technology, because many of the water utilities around the world are affected by inefficiencies, affected by lack of funding, and affected by political interference. And I understand how technology companies face these hurdles. So putting in place a water utility that's transparent, efficient, and profitable at the same time is a tough task. And looking at what is the best way to do that, is it through privatization? Is it through public? Is it through social? And what we've come up with is the fourth sector is probably the best way to put together a water utility where it is profitable, it does make money, but it has a very strong social impact and a very strong environmental consideration when putting it in place.
And so how do the other three of you feel about that analysis? I mean, is that really capturing where we need to go, and how is that affecting your ability to get your innovations out there and deployed and scaled up? So whoever wants to jump in first.
Yeah. I think the idea and the strategy behind NEOM, what you have just mentioned, is really the right one. And even the World Economic Forum said this morning that the cost of not doing anything or thinking ahead is going to be not comparable of the costs for doing things. It's going to be a huge cost if you don't do anything. It's going to be much more expensive 10 years down the line.
I'm a huge believer in the power of the private sector to solve problems, and the reason for that is that as a species, we are naturally curious and we are natural explorers. Okay? Now, the private sector can explore those ideas if government can find the right policies to incentivize that exploration and that curiosity. I'm not convinced that government does that yet, but they are always looking for ways to do it. The easier you can make it for young people, especially this emerging breed of impact entrepreneur, the easier you can make it for them to risk without risking their lives, and to take risks without risking their livelihoods, the more likely we are to find clever and elegant solutions to very deep entrenched problems.
Yeah. Ashwin, any thoughts on this context?
Not too much more to add than whatever everyone else has said.
And so let me kind of turn tables a little bit in a sense that for all of you and your work on water, what outside the realms of what you're dealing with already, what do you see as the spaces that need innovation most in dealing with the water challenge? So if this was, if you were providing advice to, if all of these people out here were angel investors, and it wasn't your own company, you're not allowed to talk about your own space, what are the other parts of the water challenge that you really see out there as needing attention and effort and innovation and resources?
I would find a way to create more protected marine reserves. You know, we need, and the same on land, by the way, but seeing as we're talking about water, I'll talk about marine reserves. I think we need to find a way to allow natural systems to regenerate at their natural rate. Yeah, they can only regenerate at a certain speed, and that's the speed that they've evolved for. And to do that, you know, a species needs a certain amount of space to find a resilient population level.
I wasn't expecting that.
Yeah.
Okay.
I would say that water is the new oil, for good and bad. Oil has had its time. It's on the way out. Water is probably, along with the air we breathe, the two most important factors for life on Earth.
And are there particular innovations or technology where you see opportunities and needs out there? Any of you that would be part of what we really need to drive towards? If you,
well, I would say building cleaner, more efficient cities would stop the wastage of water. I think a lot of water is just lost due to poor infrastructure, and a lot of cities don't even know where those leakages are. Mm-hmm. Yeah.
Mm-hmm. So, as a future customer of technology, this is a really easy one for me, because we're going to be at some stage in 2030 desalinating about 1.3 million meters cubed of water a day. The biggest challenge we have in NEOM is that we're going to be putting no brine back into the sea, because we have to protect some really pristine reef environment, and we don't want to, like I said, we want to work in a sustainable manner. So the challenge we have is what we do with the brine. Many people in the water sustainability conference across the way were talking about how it's okay to put it back into the sea, and we completely disagree with that. We need to process that. We don't see it as an effluent, we see it as something that we can utilize and process. For that reason, we will be processing it. We will be pulling out magnesium, calcium, gypsum, sodium hydroxide, caustic soda, and of course a lot of salt. So the challenge out there today is, what do we do with the salt? Because that's a lot of salt at some stage. So the challenge is out there today, and if you want to invest in something, for me it's investing in what we do with the seawater that's left after we've desalinated water.
Mm-hmm.
I'd say it's hard to look at water as like a singular issue, right? It's really like a combination of thousands of little micro problems in different parts of the world. And to that end, like I think there's no real silver bullet to this thing, but there's going to be a lot of buckshot. There's going to be plenty of solutions that'll be part of the broader picture. For us, like we chose to focus on efficiency, like the same way that energy efficiency is the lowest hanging fruit for the world's energy problems. We believe that there's a similar opportunity to just make more with what we already have when it comes to water, and that data can be a really important piece of that puzzle. But I think everyone here's solutions and approaches to it are equally like valid and valuable pieces.
Yeah, well, I think that's coming across as one of the key underlying themes here, is that we've only got so much water. We've got a series of existing sets of infrastructure. So we, at a minimum, and as a start, we ought to be increasing the efficiency and the use of that in the human habitations as population grows, and as you were saying, Oliver, the level of the percentage of, I think it was you or Atle was saying, the percentage of population living in cities is increasing. And of course, with the major use of agriculture as a major user of water, if we really increase the efficiency, we'd be doing ourselves, doing the work that really needs to be done up front. We are unfortunately out of time. We're going to have to close off, so I'd like to ask you to join me in thanking this excellent panel we've had as we wrap up this session. So thanks very much, everyone.
Thank you. Thanks, Paul.